lesson activities for lesson 30 for college algebra. We're going to use the log properties that we just discussed in the demo to expand and simplify each expression. So log base 2 of 2x, that's a product in the input. So I'm going to break that up into a sum of log base 2 of 2 plus log base 2 of x. And log base 2 of 2 is 1 because 2 to the first power is 2. So this is 1 plus log base 2 of x. All right, b, log base 3 of 9 over x squared. I've got a quotient, so I'm going to break that up into a subtraction problem of 2 logs. Log base 3 of 9 is asking 3 to what power gives 9, and that would be a 2. And then I'm going to use the power property of logs that lets you take this exponent and bring it down in front of the logarithm. So I get minus 2 log base 3 of x. Log base b of x squared times y. Break that into a sum. Log base b of x squared plus log base b of y. Then use the power property that lets you take the 2, the exponent on the x, and bring it down in front of the log. So this is 2 log base b of x plus log base b of y. Log base b of the square root of x, well, that's log base b of x to the 1/2. Square root is the same thing as raising to the 1/2 power. And then I can use my power property that lets me take the 1/2 and bring it down in front. 1/2 log base b of x. The ln of x cubed over y squared z. I'm going to start by dealing with the quotient. So this is the ln of x cubed minus the ln of y squared z. Then I'm going to deal with this product. So I have the ln of x cubed minus, and I'm going to put a big parenthesis here, open a parenthesis, because I need to subtract this whole thing, and it's going to get broken into addition. So this is the ln of y squared plus the ln of z. Then I'm going to do my power property. So I'm going to take my exponents and bring them down in front. So I have 3 ln x, and I'm going to distribute this negative sign. So it's going to be minus 2 ln y minus ln z. Okay, log base 3 of 45. So let's see, I could rewrite 45 as a product, maybe 9 times 5. Log base 3 of 9 times 5. That would be log base 3 of 9 plus log base 3 of 5. And log base 3 of 9 is 2 plus log base 3 of 5. All right, part 2, we're going to condense these things. So I'm going to use the rules in reverse. Start with the exponent rule, the power rule. So anytime you have a coefficient, pop it back up into the exponent. So you have log x plus log of z squared. And now I have a sum of logs. I'm going to squish them into a single log by taking the product of the inputs, x times z squared. All right, so for b, I have subtraction of 2 logs. I squish them together by taking the quotient of the inputs. Part c, start by the power rule. Anytime you have a coefficient, pop it up. So this is going to be log base b of x to the 1/2 plus log base b of z minus log base b of w, and then take your sum, the first 2 terms that are added together, compress those into a product. So this is log base b. I'm going to rewrite x to the 1/2 as the square root of x times z, and then minus log base b of w. And then you can take your subtraction and compress that into a quotient. So I have log base b of square root x times z over w. And D, I'm going to, first I need to distribute this -1/2. So it's actually a coefficient on both of these terms. Distribute it. So this is going to be log base b of x minus 1/2 log base b of z minus 1/2 log base b of q. Now actually, that might actually be easier if I combine the two things in parentheses before I distribute the -1/2. Let's do that. All right, so I'm just going to copy log base b of x. Then I have a minus 1/2. And then log base b of z plus log base b of q, that's in parentheses, so I can do that first. And that gets combined into log base b of z times q. Now I can pop my 1/2 up, so I have log base b of x minus log base b of z q to the 1/2. And then I'm going to combine those two logs as a quotient because they're being subtracted. Log base b of x over, and raising something to the 1/2 is the same thing as square rooting, so I'm going to write this as the square root of zq. All right, so part 3, we're applying log rules to write each of the following expressions in terms of a, b, and c and some possible numbers. So there's going to be no logs left after we have evaluated these. But we're going to have to use the log rules creatively to get rid of the logs. So I have these three givens. Log base 5 of 2 is A, log base 5 of 3 is B, and log base 5 of 7 is C. I'll let you read through the examples on your own here. We're just going to jump down to the problems. So I'm going to actually copy down because I need to scroll. So I'm going to copy my expressions down here, my equations. Log base 5 of 7 is C. Okay. All right, log base 5 of 14. So I want to take my input of 14 and rewrite it with the 2s, 3s, and 7s using multiplication, division, and exponents. So I'm going to rewrite it as log base 5 of 7 times 2 because I have 7 and 2 as inputs that I know. And then I can use my log properties to rewrite this as log base 5 of 7 plus log base 5 of 2. And log base 5 of 7 is C. Log base 5 of 2 is A. So we have C plus A, or A plus C would also be acceptable. Log base 5 of 7 over 2, well, that's log base 5 of 7 minus log base 5 of 2. Log base 5 of 7 is C. Log base 5 of 2 is A. C minus A. Log base 5 of 50. So I'm going to rewrite 50 as 25 times 2. So I have log base 5, 25 times 2. Expand that, so I have log base 5 of 25 plus log base 5 of 2. Now log base 5 of 25 is just a number. 5 to what power gives you 25? So that's 2. And log base 5 of 2 is an equation that I know. It's A. That is valued at A. Okay, log base 5 of 49 over 15. So I'm going to first expand this into a subtraction. Log base 5 of 49 minus log base 5 of 15. And then my 49 and my 15, I want to rewrite those inputs using 2s, 3s, and 7s, multiplication, division, and powers. So 49, that's 7 squared. So I'm going to write this as log base 5 of 7 squared minus log base 5. 15 is 3 times 5. And 3 and 5 are two of the inputs that well, 3 is one of the inputs that I know. 5 isn't, but we'll see what we can do with that. All right, log base 5 of 7 squared. I'm going to use my power rule to bring the 2 down in front. 2 times log base 5 of 7. And then this is going to be minus log base 5 of 3 plus log base 5 of 5. And you can't forget these parentheses because I'm subtracting log base 5 of 3 times 5. So when you rewrite log base 5 of 3 times 5, you need parentheses around the whole thing. All right, log base 5 of 7, that's C. So this is 2C minus log base 5 of 3 is B. And then I'm going to distribute this negative. So I have minus log base 5 of 5, which is 1. 2C minus B minus 1. Log base 5 of the square root of 2. Hint, rewrite the radical with an exponent. It's weird that that n is missing. Okay, so this is log base 5 of 2 to the 1/2. Use the power rule to bring the 1/2 down in front. 1/2 times log base 5 of 2. Log base 5 of 2, I'm pretty sure is A. So this is 1/2 A, or A over 2. All right, log base 5 of 36. So I'm going to rewrite that 36 using 2, 3, and 7, multiplication, division, and exponents. So 36, maybe, All right, I think I'm going to rewrite 36 as 4 times 9. And the reason I'm choosing 4 and 9 is because 4 is 2 squared and 9 is 3 squared. And 2 and 3 are the inputs I know something about. So now I can expand this. This is log base 5 of 2 squared plus log base 5 of 3 squared. Just rewrote the 4 as a 2 squared and the 9 as a 3 squared, and I applied a log rule. Now I'm going to use my power rule that I can bring the exponents down. So this is 2 log base 5 of 2 plus 2 log base 5 of 3. So that is 2A plus, oh, I think it's 2B. Log base 5 of 3 is B. Yeah, 2B. Okay, log base 5 of 1 over 21. All right, so first I'm going to rewrite this as log base 5 of 21 to the negative 1. And then I'm going to bring the exponent down in front. So this is negative log base 5 of 21. Then rewrite 21 as 7 times 3, negative log base 5, 7 times 3, negative. Make sure you put parentheses because I'm going to replace log base 5 of 7 times 3 with a sum. Log base 5 of 7 plus log base 5 of 3. So this is negative C plus B, or negative C minus B.